All right, guys. Today we're going to go over this geometry problem from Waterloo's grade 12 Euclid contest. This is question number 5b from year 2012, and the question says, PQRS is an isosceles trapezoid with PQ equals to 7, PS equals to QR equals to 8, and SR equals to 15. Determine the length of the diagonal PR. So there are many kind of methods or approaches. So in the approach that I'm about to show you, which is different from the official answer, right, you need to know three key pieces of information. And the first one is the property of isosceles trapezoids. Trapezoids, right? Isosceles trapezoids are kind of like isosceles triangles. We know that the sides on the left and right, they're exactly the same. And we also should know that the angles on the bottom, right? So PSR and QRS, they're also the same. And moreover, the angles on the top, right? They must also be the same. So SPQ is equal to PQR. And we also know that for trapezoids, right, we have one pair of parallel lines, so the top and bottom, right? And since the top and bottom are parallel, then we know that the blue angle, angle A, and the angle of the top, right, angle B, the red one, they must add up to 180. So angle A plus angle B is 180. Okay, so that's the first piece of information. Then for the second piece of information you need is the cosine law. The cosine law states that for any triangle, right, if you have sides A, B, and C, then side C squared is equal to A squared plus B squared minus 2 of side A and side B, right, times cosine of angle C. Remember, angle C is the angle formed by side A and side B. Then for the third piece of information that you need is actually this compound angle identity. So cosine of A plus B, right, is equal to cos A cos B minus sine A sine B. Okay. So you should know like these knowledge by around grade 12. Okay, so now we have enough information to start cracking this question. So the question asks for the length of PR diagonal, right? This diagonal right here. Let me just relabel the angles, right? Since the left one is B, then the top right is also B, right? So I've essentially split this trapezoid into two triangles. If I know the measure of A, then I can find this diagonal. Let's call this C. Right? If I know the measure of A or the measure of B on the top, then I can find out the length of C using the cosine law. But the problem is I don't know what angle A and angle B are, right? So, but I do know that they do share one side, which is this diagonal C, right? So let's outline that relationship. So we know that C squared, this diagonal square, is equal to, let's look at it from the bottom perspective, right? So that's 8 square plus 15 square plus minus 2, 8, 15 cosine angle A, right? So that's the cosine law, right? And if you look at it from the top perspective, this triangle, then it's a pretty similar, right? 7 square plus 8 square minus 2, 7, 8 times cosine, this time, B, right? And I have essentially created an equation, right? This equation, right? They're all equal because they both point to C squared. But I have two variables. I have angle A and angle B. So can I kill any one of them? Of course you can. Remember, right? From the previous discussion, angle A plus angle B, right, is 180 degrees. So for angle B, I can replace that with 180 minus A. Okay, so I'm one step further, right? At least I got rid of a different angle. Except that, on the left side, I have a cosine A. On the right side, I have a cosine 180 minus A. It's still really hard to collect the like terms. They're not exactly 100% alike. So how can I get rid of the cosine 180 minus A? Well, you can use the compound angle identity that we just talked about. So cosine 180 minus A, right? We can replace that with cosine 180 cosine A plus, right? Because you have minus, right, back in here. So that's sine 180 sine A. So we know that cosine 180, if you know the graphs, that's -1. So this becomes negative cosine A. And sine of 180 is just 0. So the second term becomes 0. So this is just negative cosine, right? So we know that when we see this thing right here, we can just replace it with negative cosine A and the equivalent. Okay, that pretty much clears clears all the obstacles, right? So we can solve this as a system of linear linear equations. So we have 8 squared plus 15 squared minus 2, 8, 15 cosine A, right? The left side. Then the right side is 7 squared plus 8 squared. Now since I replaced this thing with negative cosine A, right? Then this becomes plus 2 times 7 times 8 cosine A, right? After I take care of the negatives. Then we can start solving for cosine A. So let's cross out the unnecessary, the redundant constants. So 8 squared and 8 squared they cancel out. So I'm going to collect all the constants to the left. So 15 squared, I'm going to take this 7 squared to the left, so it becomes minus 7 squared. Then I'm going to take all the cosine terms to the right. So this term, right, if you move it to the right, it becomes positive 2, 8, 15 cos A plus 2, 7, 8 cos A, right? Just rearranging it. Then let's collect the like terms together, right? So the left side simplifies down to, I believe, 176, right? On the right side, if you collect all the cosine A's together, then the coefficient becomes 352 cosine A. And that means, right, 176 over 352 is equal to cosine A. That means 1/2 is equal to cos A. And based on that, you can, based on the special triangles, you know that angle A is actually 60 degrees. But that's a little bit redundant, right? Remember, in order to calculate c squared, right, based on this formula, we just need to know what's cosine A. And I know exactly cosine A is, right? It's actually just 1/2. So we can go back to that formula and just replace cosine A with 1/2. So I've cleared the work, right? So let's just plug in 1/2 for cosine A. So 8 squared plus 15 squared minus 2, 8, 15. This is 1/2. And if you do the calculation, c squared, right? Remember, this is not c, this is c squared. C squared is equal to 169, which means that c, this is the PR diagonal, must equal to 13. And that is the answer.